Hello guys, welcome back to today's class where we'll be looking at another subsection of functions. So today we'll be randomly looking at questions, that is miscellaneous questions under function, that is combining all our idea of inverse of a function, composite functions, and as well basic functions. So we'll be looking at how we can actually apply these principles to solve everyday questions on functions. Okay, so let's take the following examples and please come along with me. So we have an example here. Under random examples of functions. The first example here says that was given that f of x plus 2 is equals to 3x squared minus 4x plus 2. Find the values of figure 1, you have f of x, figure 2, you have f of minus 1. Now, if you look at this question, you will see it is, unlike the previous questions that we have been doing, we are not actually giving our f of x. We are not actually giving the function in its original state. We are given a function which is relative to the original function. That is, instead of them giving us f of x, instead of them to give us f of x as the function, and then tell us to find a particular thing, they are giving us f of x plus 2, and then telling us to find the original f of x. So in this case, we'll be reversing, it will look like as if we are reversing the ideas we use in doing the initial one. So what do you do here? It's a very simple procedure to get our f of x, where our f of x plus 2 minus 4x plus 2, we simply do what? We simply need to kind of reverse this idea. So now we have f of x plus 2 equals to 3x squared minus 4x plus 2. All we need to do is what? We introduce a new letter. We can say let h. We can introduce letter h. And say let h be equals to x plus 2. Since our h is x plus 2 here, we make h this value. So in such a way, we are making this function become function f of h. So you see, let h be equals to x plus 2. So if h is equals to x plus 2, it means that if we want to make x, making x the formula, making x the subject of the formula, we simply get, we simply derive, we derive our x to be what? To be h minus 2. Since our x is now h minus 2, we can now say that since x is equal to h minus 2, then our f of x plus 2, now have f of h is equals to 3x minus 4x plus 2. Therefore, our f of x, this is also the same as f of x plus 2. So now I can just say my f of x now, I simply substitute this value that I've gotten here for x in this equation. So it becomes 3 into bracket. We have 3 into bracket. Since x is now h minus 2, we just substitute it there. H minus 2 squared minus 4 h minus 2 plus 2. Expanding this, we have 3 into h minus 2 times h minus 2. Opening this as a bracket, we have minus 4h plus 8 plus 2, giving us a quadratic expression, a quadratic function of minus 4h plus 4 minus 4h plus 10. This is giving me 3h squared minus 4h minus 12h rather. So we are opening the bracket with 3. That means we have 12h here plus 12 minus 4h plus 10. This gives us 3h squared, collecting like terms and simplifying, minus 12h minus 4h, we have minus 16h, plus 12 plus 10, we have plus 22. So this becomes our f of x plus 2. So this is our f of x plus 2 in terms of h. But we want to regard it in terms of x. So what do? We simply say what? Therefore, we let f of x represent f of x plus 2, where x represents h. So what do? In short, this one becomes f of x, and then instead of h here, it becomes x. So we have 3x squared minus 16x plus 22. And this becomes our original function. So this is the way to actually approach this kind of question. First of all, you introduce a random variable that was not used, and then you try to make x the formula. After doing that, you can now substitute it back into the equation before representing our f of x plus 2 as f of x, and then our h for x. So it's a very simple listing. Let's go to our Roman figure 2. For Roman figure 2, we're told to find the f of particular value. Told to find the f of minus, was it 2 or 3? Minus 1. Told to find f of minus 1. So if you are going to get f of minus 1, you are looking for f of minus 1. Now, there are two ways I want us to look at this. The first way will be if you have not gotten our f of x, that is from the original function. If you have got from the original function where we are given our f of x plus 2 instead of f of x to be 3x squared minus 4x plus 2, I can simply say what, the first thing I'll do is I want to get f of minus 1, and I'm giving f of x plus 2. I can easily just equate this minus 1 to x plus 2. Because what? This is not a simple function. It is not in its normal state. On a normal day, the function given should not have an extra plus 2. It should just be f of x. But because it has an extra x plus 2, I must get the value of x itself before I can now substitute it inside it. So the only way to get that value is actually to what? Equate x plus 2 to minus 1. So how do I do that? I simply say what? X plus 2. This x plus 2 here equates it to minus 1. Whatever value of x I get is the value of x that I'll be using to substitute. So I have x here. X equals to minus 3. I've gotten my x, then I can now say therefore my f of minus 1 now, instead of substituting minus 1 into this function, I'll be substituting minus 3. So I have 3 into bracket minus 3 squared minus 4 into minus 3 plus 2, giving me 3 into 9. Minus 4 and minus 3 gives me plus 12 plus 2. Here I get 27 plus 14. I can see my f of minus 1 equals to 41. This is one way I can go about it if I have not yet gotten my f of x. But since I've gotten my f of x from Roman figure 1, another way I can go about it is by using the f of x I've gotten. See, I can say from Roman figure 1, we got our f of x. we derived our f of x to be 3x squared minus 16x plus 22. So that's what I'll be using in this case. 3x squared minus 16x plus 22. So since I've gotten f of x here, I can just easily say, therefore, my f of minus 1 now will be simply substituting my minus 1 into this. That is about 3 into minus 1 squared minus 1 plus 22. This will give me 3 into minus 1 squared is 1, minus 16 times minus 1 is plus 16 plus 22. This gives me 3 plus, if I adding these two, I have 38, giving my f of minus 1 to be 41 again. So if you look at it critically, you realize that the same 41 we got here is the same one we got here. So any method you use, if you use your f of x plus 2 that was given in the original question, or you use the f of x that I have not gotten from Merriam figure 1, if you are doing the right steps, you are making the right procedure, you are going through the right procedure, you get the same final answer, which is the correct one. So that is how we attack questions like this. So see you in the next class when we look at a new topic in polynomial.